Lesson 10, Transforming Angles. Angle measures in parallel lines. In this lesson, we'll describe the effects of a rigid transformation on a pair of parallel lines. Talk about how if I have a pair of vertical angles and I know the angle measure of one of them, I can use vertical angles to determine missing angle measurements. And we should be able to identify congruent angles on two parallel lines cut by a transversal and use that to determine missing angle measurements. We've been talking a lot about congruent things, and we're going to focus our next 3 lessons on congruent angles. And there's a few ideas that are going to be useful for finding angle measures that are congruent. Let's take a look at this first slide, or probably slide 3 for you, on vertical angles. So here's 2 ideas that will be useful in today's lesson. First of all, angles that are across from each other, like A and B are in this picture, are called vertical angles. You can see that they share the same vertex, but the sides of those angles are not common. They're kind of diagonal from each other. And the second idea that's going to be useful is that transformations, like the ones we've been talking about, can be used to prove that some pairs of angles are congruent. For example, let's use a single transformation to show that angle A on the left and angle B are congruent. Well, I don't think I'd be able just to slide angle A over. I can't translate it, but pretty sure I can rotate it. Let's go ahead and define the angle and the center of rotation. Well, my center of rotation is going to be right there at the vertex that these 2 angles share. And I'm going to swing this angle around 180 degrees. So let me just move that angle of rotation to 180 degrees. And let's take a look at what happens when these angles that are made of 2 intersecting lines are diagonal from each other. Here we go. Yep, they're congruent to each other. Now, instead of getting a sheet of paper and some geometry tools, we're just going to cut to the chase here. And ask ourselves some things about congruent angles. Now, what's important in this figure on the left is that the 2 lines are parallel. I'm going to highlight those for you here and talk just a little bit, make a bigger highlight, talk a little bit about the symbol that's used to show that things are congruent, not congruent, parallel, and what that means for us. So the 2 orange highlighted lines have these little symbols here, these little arrows. And in geometry, that means that the lines are parallel to each other. And if they're parallel to each other, we can make some assumptions here about which angles are always congruent to angle A. Okay, we've talked about these 2 orange lines being parallel. I'm going to get rid of that so that we can focus a little bit more on angle A. Here it is. So which ones are always going to be congruent? Well, we just talked about vertical angles. And it seems like this one that is diagonal from angle A looks to be about the same size. I'm going to make these parallel lines a little bit different, and just to confirm that, yep, this vertical angle for angle A gets bigger when A gets bigger, and it gets smaller when A gets smaller. I've made A really small now, and that vertical angle to A is also pretty small. Put these parallel lines back. So which angles are always congruent to A? Well, I know that one probably is. It's a vertical angle, and we just got done talking about that. I could rotate it, and it would land right on top of angle A. But it seems like there's some other ones too. You know what? I'm going to make angle A really big again, just so I can see which other angles get really big. So the vertical angle I originally looked at is still congruent to angle A. But there's some other big angles down here too. It looks like this angle from the parallel line and this angle that's vertical to it would also be congruent to A. Now, if the lines aren't parallel, like in this figure, I can't say the same thing. It says here lines M1 and M2 are not parallel. And you don't see, let me just highlight those lines again so we know which ones we're talking about, this line and this line. Those aren't parallel. So they don't have those little arrows to indicate it. And if I move one of these lines, only that line moves. It's not like the last figure where both of the parallel lines moved together. So when I change the shape of A in this circle, nothing happens down here. I don't think those angles at the bottom have anything to do with these angles that go with the top line. So it looks like these vertical angles, A and the vertical angle to A, are still congruent. But because the lines aren't parallel, this other circle doesn't have anything to do with anything. All right, let's take a close look at this figure. So I want to introduce the word transversal here because I've got one long line that passes through three other ones. And you'll hear that being referred to as a transversal line. Let me just highlight it here. That's our transversal line, and it cuts through these other lines. There's three other lines. And you can see that the line on the very top and the line on the very bottom are parallel to each other. So that means something when we're talking about angle measures. It also means something that this line in the middle is not parallel. That means that we don't know anything about these four angles. So let's come back and take a look at which angles must be congruent to angle A. Well, we know that the vertical angle is going to be congruent. And if I were to translate this angle all the way down to this bottom line, because the bottom line and top line are congruent, I can say that that angle is also congruent to angle A. And since that's congruent to angle A, the vertical angle to that is going to be the same as well. So you'll notice that there's some angles connected to each of the parallel lines that are going to be congruent to A. But I didn't click on anything from this line that wasn't parallel. I don't know anything about those angles in that circle. So if these are the angles that we said have to be congruent to angle A, for each one, I should be able to use a single transformation to convince somebody that I'm right. So let's do that for each one of these. I'm going to start by doing what we did before. Let's look at this angle and do a transformation that would map A onto this angle here. I think we need a rotation for this. So I'm just going to drag that center of rotation right there. And this is going to be 180 degrees. And we can see that, just like before, those vertical angles are congruent. The two with the other parallel line down here are going to be a little bit different. To map angle A onto this angle, I'm going to translate. Let me just translate from the vertex of angle A all the way down to the vertex of this angle and see if that works. And there it goes. It's going to slide right down there to the corresponding to the parallel line that goes with it. That leaves just one more. This is a little bit trickier, but it's another rotation. So let me reset this. And back to angle A. I'm going to rotate, but my center of rotation is going to be halfway between these two angles, these last two angles. So I'm going to bring my center of rotation right about there. That looks about halfway between the vertex of A and the vertex of my last congruent angle. I'm going to rotate 180 degrees. Well, I'm going to try to rotate 180 degrees. There we go. And there it is. So angle A has three congruent angles if I know that I have two parallel lines. And I know that because I have these arrows on these two lines to indicate it. All right, now this gets a little bit hairy, but let's see if we can keep our eyes focused on what's important. I'm going to go back and highlight a few things. So we're asked to first click once to show each angle that's congruent to angle A, this one over here. Well, I'm going to make sure I'm looking at the lines that make up angle A. I don't want to mess that up. Let me see if I can make this a little smaller. Okay, so the lines that make up angle A are that line and this line. So that's important for me to make sense of because I want to make sure that I identify the vertical angle correctly. Okay. So if that's angle A, then this angle should also be congruent. Now, I also want to point out that I have some parallel lines here. This line and this line are parallel to each other. So if this angle A, if this is angle A and it's parallel to this line, think about what would happen if I translated angle A right down here. I think that angle would also be congruent to A, and there's the vertical angle to that one. Okay, and I think that's about all we can say for angle A. Yep. Now I'm going to get rid of the red highlighting and then focus on angle B. We're asked to click twice to show each angle that is congruent to angle B. So I'm going to focus on some different lines this time. I'm looking at the angles that make up angle B, not the same ones as the ones that made up angle A. This time it's this line that's coming all the way down to this parallel line. These are two parallel lines again. So now as I'm looking at B and trying to figure out what the vertical angle to B is, it's going to be on this diagonal side. So angle B, told me to double click on that. There's angle B. Think what would happen if we slid this or translated it all the way down. It's going to be a small angle. Get sure it's double clicked. So B is down here, and the vertical angle to that as well. All right, so we found all the measures that are congruent to angle A and all the angles that are congruent to angle B. We're asked to explain how we know by describing the transformations I might use. Well, for the vertical angles, I can rotate the original angle. For angles that are on the other, that match up in the same spot on the other parallel line, those are translations. And the angles that are vertical to those are rotations. So rotations or translations will help us to identify congruent angles. Let me scroll past these learning goals that we discussed earlier when the lesson opened and take a look at two vocabulary words that you should fill in on page 43 of your math notebook. One thing we talked about were vertical angles. So let's nail that down a little bit. Vertical angles are opposite angles that share the same vertex, and they're formed by a pair of intersecting lines. And you see some examples here. Whenever I have intersecting lines, the opposite angles have the same degree measure. You can see these two that are 139 degrees and these two that are 37 degrees. Now, these are not examples of vertical angles. I mean, there's still some intersecting lines here, but these angles aren't opposite each other. They don't share the same vertex. So vertical angle measures are always equal as long as they're on opposite sides of this X made up by the two intersecting lines. And the other word I used was transversal. A transversal is a line that cuts across two other lines. And you'll see this one here in the example. Line AB, that kind of goes diagonal here, is a transversal that intersects line CD and line EF. Now it says they're parallel here. If they were parallel, they really should have those little symbols, those little arrows to indicate that they're parallel. But that's a transversal. On the right here, this is not a transversal because it doesn't cut across two lines. And a pair of parallel lines intersected by a transversal forms pairs of congruent angles. So let's finish up with looking at the summary task on the guided notes and talk about what we'd be able to tell from this figure. We see a pair of parallel lines. I'm going to highlight the symbol again. This line is parallel to this line. And there's that transversal line right here. Transversal that cuts across those two parallel lines. And we're asked to use what we know about angle relationships to determine the measurements for all of the other angles in the diagram. All of them, not just the congruent ones. Well, let's start with the congruent ones. Okay, I think we can do this. So if this is 145 degrees, then the angle vertical to it is also 145 degrees. I'm just going to mark it with a blue dot to indicate that it's the same as the 145. And since I know that I have two parallel lines, let's look at this bunch of angles here and see if any of those are 145. I should be able to translate that 145 degree angle right down here to this intersection. That should be 145 degrees. And this should be 145 degrees as well because it's a vertical angle. So all the blue dots are 145 degrees. Just write that here. Sorry, I'm writing with my mouse. But we were asked to find all of them. And if we think just a little bit, I'm going to just mark this line real quick. Now, there are 180 degrees in a line. And if the blue dot represents 145 of them, then I should be able to find the rest of those degrees that make up 180. So if all of this is 180 degrees, I should be able to take 180 and subtract 145 and be left with 35 degrees for that. I'm just going to get a pen here. 35 degrees for that angle measure there. Well, if this is 35 degrees, this little wedge right here, then the vertical angle to that is also 35 degrees. I'm just going to mark it with a dot. That's 35 degrees. I can translate that down to the parallel line here, and this would be 35 degrees. And the angle that's diagonal to that would be 35 degrees. So all of the orange ones are 35 degrees. So you'll find that these are like little puzzles, kind of fun. But we looked today at vertical angles and transversals. So in this lesson on angle measures and parallel lines, we were able to describe the effects of a rigid transformation on a pair of parallel lines. We knew that if we had a pair of vertical angles and we know the angle measure of one of them, you can use vertical angles to determine the missing angle measurements. And we identified congruent angles on two parallel lines cut by a transversal, and we used that to determine missing angle measurements.